Welcome to the lecture number 18. Same geometrical constructions, practice at 4.2. Question number 6. Draw a circle with center P, radius is 3.4 cm. Take point Q at a distance of 5.5 cm from the center. Construct tangents to the circle from point Q. Try to understand this rough sketch. This question will also carry 4 marks. So, first of all, you have to draw a circle of radius 3.4. Then, from PQ is a distance 5.5. So, take point Q at a distance of 5.5 from P. After taking this point Q or after plotting point Q, you will be getting segment PQ. Then you have to draw a perpendicular bisector of PQ. Very simple method. Placing meeting point at P, taking distance more than half, draw 2 arcs, one above PQ, second one below PQ. Without changing the distance, simply interchange the position. Place the meeting point at Q, draw intersecting arcs to the previously drawn arcs, draw a perpendicular bisector, then point of intersection of PQ and this perpendicular bisector, if I call it as M, then taking M as a center, you have to draw a circle passing through P and Q. I repeat again. By taking M as a center, you have to draw a circle passing through P and Q. When you draw this circle intersects the previously drawn circle of radius 3.4 in points A and B. In points A and B. See here, the circles are intersected. Then through point Q and A, draw a tangent. From Q and B, draw a tangent. So this is how we have drawn 2 tangents, namely QA and QB from point Q, which is at a distance of 5.5 from the center P. The radius of a circle is 3.4. Same things we have to do on right hand side of our fair figure. So first of all, let's draw a circle of radius 3.4. 3.4. Placing metal point of rounder at 0. 3.4. Center of a circle is given P. Draw a circle of radius 3.4. Finish drawing circle of radius 3.4. Next to that, from point P, we have to plot point Q, which is at a distance of 5.5. Which is at a distance of 5.5. So, take a distance of 5.5 from where? P. And plot point Q. PQ is 5.5. Okay. I'll label the figure later. Next step, as I explained, next step is to draw perpendicular bisector of PQ. To draw perpendicular bisector of PQ, place meeting point on P, take a distance more than half. Draw 2 arcs above PQ as well as below PQ. Draw 2 arcs, one is above PQ, one is below. Not to change this distance, place meeting point on Q, draw arcs intersecting the previously drawn arcs. I repeat, placing meeting point on P, take a distance more than half, draw 2 arcs. Without changing the distance, placing the meeting point on Q, draw 2 arcs to the previously drawn arcs. Then, through the point of intersection of these arcs, draw a line. passing through this point of intersection of the arcs. This line bisects PQ at point M. Here I have drawn perpendicular bisector. This perpendicular bisector intersect PQ in point M. At once you will get point M. Taking M as a center, this is important. Taking M as a center, radius is equal to PM or MQ. PM and MQ. Draw a circle. Draw a circle passing through P. Draw a circle passing through P as well as Q. See once again. Perpendicular bisector intersects PQ at M. Taking distance is equal to MQ or PM. Draw circle. Now this newly drawn circle with center M intersect the previously drawn circle in 2 points. Label these points as A and B. Same way. Label these points as A and B. Now next step is to draw the tangents. How to draw tangent? Through point Q and A, draw tangent. Through points Q and A. So QA is required tangent. In the same way, draw tangent passing through Q and A. Now here you will find our construction is over. We have drawn QA and QB are required tangents. Now see what is left out. P, then show the radius from here 3.4. 3.4. PQ. Point Q is at a distance of 5.5. This is perpendicular bisectors. Finished. This is our required construction. 4 marks. Required figure. This is rough sketch. I am going to repeat all the things again. First of all, I draw a circle with center P of radius 3.4. Then from P, I plot a point Q at a distance of 5.5. Then I draw perpendicular bisector of P. For drawing perpendicular bisector of PQ, I place middle point on P. Taking distance more than half, I have drawn 2 arcs. Without changing that distance, I place middle point on Q and I have drawn 2 arcs intersecting the previously drawn arcs. Then, through the point of intersection of these 2 arcs, I have drawn a perpendicular bisector of PQ. Perpendicular bisector of PQ is intersecting PQ in point M. Where it is intersecting at point M. Then, place a middle point on it. Take radius as PM or MQ. Take center as M. Draw a circle which is passing through P as well as Q. This circle will intersect the circle of radius 3.4 in points A and B, then through point Q. Join QA and QB, so you surely find that QA and QB are required tangents. QA and QB are required tangents. So here we find that I finished question number 6. Now let's do the question number 7. This is also of the same type. Question number 7 is also of the same type. In question number 7, draw a circle. Draw a circle of radius 4.1 centimeter. 4.1 centimeter. Construct tangents. Construct tangents. Construct tangents to the circle from point to the circle from point at a distance of at a distance of 7.3 centimeter from the center. Same figure, I need to say some construction is of same pattern. Rough figure. What we have to do? Let's draw a circle. After drawing this circle, radius is 4.1. Rough sketch. Then you have to take a point, center of a circle. Okay, any point you can take. P. Take point Q at a distance of 7.3. 7.3. 7.3. If I take this as 7.3 centimeter, rough sketch. So PQ is 7.3. Next to that is perpendicular bisector. We have to draw a perpendicular bisector of this PQ. Label it as M. Label it as M. Then we have to draw. We'll surely find by taking M as a center. M as a center. Draw a circle. Now this newly drawn circle will intersect the circle of radius 4.1 at 2 points A and B. A and B. Next step is this is how we will be getting QA and QB. QA and QB are required tangents. So there is no difference in the previous sum and this sum. Method is same. Method is same. Method is same. So we'll find it. First, let's draw a circle of radius 4.1. So take P as we have shown in the rough sketch. 4.1. Supposing this is my scale, placing measure point at 0, taking distance of 4 point. Draw circle. Circle is over. Then we have to take point Q. At what distance? 7.3. See here, at a distance of 7.3. So from P, you take point Q as 7 point. If I take this as Q, PQ is 7.3. PQ is 7.3. Okay. After that, after locating point Q, next step is to draw perpendicular bisector of PQ. Perpendicular bisector of P. To draw perpendicular bisector, place middle point on P. Take distance more than half. Draw two arcs. I repeat again. Place middle point on P. Take a distance more than half. Draw two arcs. Very important not to change this distance. Place middle point on Q. Draw two arcs to the previously drawn arcs, and these arcs are intersecting each other. Through the point of intersection of these two arcs, through the point of intersection of these two arcs, draw perpendicular bisector. See, this is the point of intersection. This is also a point of intersection and two arcs. This is how you finish. I have drawn perpendicular bisector of PQ. Label that point as M. Next thing is, take M as a center and draw a circle passing through P as well as Q. Now I am going to place middle point on M, MQ and PM. These are the radius. Very simple. MQ. Draw a circle. Draw a circle. So this is how I draw a circle passing through points P and Q. This is our original circle, right? And radius of our original circle is 4.1. So I'll label it as. Now this newly drawn circle with center A intersect the circle of radius 4.1 in 2 points. See, this is originally drawn circle, this is newly drawn circle. They are intersecting at points N. Next step is to draw tangents from point Q and A as well as from points Q and B. QA and QB are the required tangents to the circle. So this is required figure. QA and QB are required tangents to the circle. I have written more elaborate that required tangents to the circle is center P. What is left out? PQ is 7 point. Now let's have a review. First, I have drawn a circle of radius 4.1 cm. Then I plot a point Q from P at a distance of 7 point. Then I draw perpendicular bisector of PQ by placing metal point on P. Distance more than half, I draw two arcs on both sides of PQ. Without changing that distance, I place metal point on Q. I have drawn intersecting arcs to the previously drawn arcs. Through the point of intersection of those arcs, I have drawn this line. This is a point of intersection of PQ and perpendicular bisector that I label it as N. Placing metal point on M, radius PM and MQ, I have drawn a circle which intersect the previously drawn circle in two distinct points, namely A and B. Then through point Q, A, I draw tangent, first tangent and second tangent I have drawn passing through Q and B. So this is how you will find QA and QB are required tangents. So here question number 7 is over. Now you find, dear students, I'm going to begin now, right? I'm going to begin now problem set. Problem set. Problem set. Problem set 4. Question number 1. Sub question 1. These all are MCQ type of questions. So first question is the number of tangents. The number of tangents. The number of tangents. Can be drawn to a circle. Can be drawn to a circle at a point on the circle, at a point on the circle, at a point on the circle is, option is very simple. Option is C, that is 1. Answer of this is, right, C, and that is 1. We can draw only 1 and 1 because tangent and circle intersect in only 1 and 1 point. That is a definition, right? Point of intersection is only 1. So we can draw only 1 tangent. Second one is the maximum number of tangents. The maximum number of tangents. Maximum number of tangents that can be drawn to a circle. That can be drawn to a circle from a point outside it. Answer is A, option A. 2. If I draw this circle, this is point Q. Sorry. How many tangents you can draw? At the most 2. not more than that at all. Because condition is that those tangents must pass through point P also. So only at the most we can draw two tangents. Third one, triangle ABC. Triangle ABC, similar to triangle PQR, AB upon PQ is equal to 7 upon 5. Then triangle ABC is bigger. Very simple. Triangle ABC is bigger. So we'll find that why triangle ABC. Right. Very simple. If you look at the ratio, then you will surely find all sides of ABC are having the ratio of 7:2. All sides of PQ are having the ratio of 5. So they are in the ratio of 7:1. Very simple. So naturally you will be getting that triangle ABC is bigger than triangle PQR. So here we finished. Very simple. This you can say. All these questions are very simple. That first one, the number of tangents that can be drawn to a circle at a point on the circle, one and only one, because tangent and circle intersect each other in one and only one point. Second one is from exterior point, how many tangents you can draw to the circle? Two tangents at most, not more than it. Third one is third question. That triangle ABC and triangle PQR are similar to each other. AB upon PQ is 7:5, and naturally you find all sides of AB are larger than that of sides of triangle PQR. So triangle ABC is bigger. Fine. So here you will find we finish the first question of the problem set. Let's do the second construction. Second construction of this problem set. All sums are same in the problem set that we have solved, same as that of the practice set. Question number 2. Draw a circle. Draw a circle. With center O. With center O. Radius 3.5. Radius is 3.5. Take point P. Take point P at a distance of 5.7 from the center. From the center, and draw tangents from point P. First thing, 4-mark question, rough sketch. Draw a circle. Radius of a circle is how much? 3.5. Radius of a circle is 3.5. Supposing if I draw a circle. of radius 3.5. Center, name of the center is zone. Center is zone. OP is how much? OP is given as 5.7. OP is 5.7. OP is 5.7. So we locate point P at 5.7. After plotting point P, what we have to do? We have to draw perpendicular bisector of this OP. Perpendicular bisector of OP. Label that as point M. After getting point M, draw a circle passing through O as well as P. Draw a circle passing through points O as well as P. Now this newly drawn circle with center A are going to intersect the previously drawn circle of radius 3.5. Say point A and P. This circle has intersected the newly drawn circles are intersecting each other in points A and P. Radius of circle is 3.5. So this is how we will find that this is our PA and PB are required tangents to the circle. These are the required tangents to the circle. Now first of all we have to draw a circle with center O radius 3.5. 3.5. Please try to understand. Place a metal point on 0, very important, and then take 3.5. Now this time center is 0. Draw a circle. Draw a circle. After drawing circle with center O, next step is to take point P. Take point P at a distance of 5.7. At a distance of 5.7. So please take this point P at a distance of 5.7. Join O. Join O. Join O. After joining OP, distance of OP is how much? It is 5.7. Draw perpendicular bisector of OP. Place metal point on O. Take distance more than half. Draw two arcs. Finished. Don't change this distance. Very important. Place metal point on P. Draw arcs intersecting to the previously drawn arcs. Again you see. Same distance. Draw a perpendicular bisector. Draw a line passing through this point of intersections. See here. point of intersection of the arcs. Label that point as N. Label that point of intersection of OP and perpendicular bisector Z. Then I am going to draw a circle passing through O as well as P. Placing major point on O, P. It is very important to note, dear students, you must have to draw a complete circle. If somebody will teach you to draw only simply the arcs intersecting the previous arcs, that is wrong. I forgot to tell you. It is very, very important. These things must be as I am going to show you. Very important. So by taking OM as a radius, LP as a radius, draw complete circle, not simply these arcs. Wrong. Absolutely wrong. If somebody is guiding you in that way, wrong. Point of intersections are A and B. So you will find this newly drawn circle is intersecting the previously drawn circle in 2 points A and B. Our construction is more or less over. Draw PA. Please here. Draw PA and draw PA and draw PA and don't forget to level the figure properly. Radius of circle is 3.5. OP is how much? 5.7. So here this is a, you can say, fair speech or required figure. Required figure. PA and PB are required tangents. To the circle. Okay, so first, please, let's take a review of this construction. First of all, I have drawn the circle of radius 3.5. After drawing the circle of radius 3.5, I have brought the point P and a distance of 5.7. Then I join OP. After drawing that, I draw a perpendicular bisector. After drawing perpendicular bisector, for that I place middle point on O. Taking distance more than half, I draw one arc above OP, second arc below. Then without changing that distance, I place a middle point on P and then I draw intersecting arcs. Then from the point of intersection of these arcs, I draw a perpendicular bisector of OP that intersect OP in point M. Then taking OM as radius or MP as a radius, I am drawing a circle. Now this circle will intersect the previously drawn circle in points A and B. Then join PB and PA. So PA and PB are required tangents. So that's all. You'll find here we have already started this problem set 4. Second question is also over. In our lecture number 81, we'll continue with the same, that question number 3 of the problem set. Thanks a lot to dear students for watching these videos. Repeatedly we are doing the same sums again and again. Only you have to do a good practice. Neatness is required. Labeling of the figure is also very important. Rough sketch is important as and when it is required, because it requires, because reason being that 1 mark is reserved for it. That's all. So I'm going to conclude this lecture number 18. God bless you all. Thank you.